The last thing that I want to talk about today is evaluation. Thus far, we've been focused on intrinsic evaluations. Whether you correctly predict spoilers or not, assigning words and documents to a correct category. Intrinsic evaluations measure the specific tasks that you're training a classifier or other system to perform. But this isn't always the most realistic evaluation. What makes for a more realistic evaluation is an extrinsic task, such as the number of spoilers that a user sees on a social media system, the number of relevant documents returned by an IR system, or if you're making a computer vision process as a part of an automated milking system, whether or not an image has a cow or not could be an intrinsic evaluation, but how well that milking system provides milk would be an example of an extrinsic evaluation of that system. And when you're building these systems and you're trying to get people to use them, or you're trying to get your boss to give you money and resources to implement a system, oftentimes you'll have a more convincing story if you use an extrinsic evaluation than an intrinsic evaluation. So what else can you do to create a convincing story that these methods are doing what they should and prove that you have a good method? So first, you need to establish that the problem is hard. And you need to firmly establish the baseline that you're going to build up from. If the problem is trivial, then it's not worth doing. So we've talked about some good baselines for performance, measuring the most frequent class. How well would you do if you just randomly guessed an answer? These are very simple baselines. A stronger baseline would be to use current best practice. So use the obvious features and, say, an SVM or decision tree and see what kind of performance you get. That should be your starting point, and that should be the thing that you report first. Whether you're trying to sell your boss on a particular machine learning technique, or if you're trying to write a paper. Hopefully, you then create a method that improves upon these baselines. Once you do that, you absolutely need to give qualitative results. Give examples of what went well. Where did your method do well, get the right answer, and also where it went wrong. So the error analysis process that I told you about for discovering new features also helps you see and communicate how well your algorithm is doing and gives intuitions for people about why this is a hard problem, why this is perhaps an easier problem, and in the end, tell a story. And so this brings us back to the very first homework that you did in the class, where you had to tell a story about some data. And so now you're telling a story not just about raw data, but also about how your techniques are performing on these data. You can think about baselines as before you came along. So show that it's an interesting problem, that it's not trivial. You can think about the qualitative results as explaining the now. What is the best you can do? What is your algorithm doing now? And then the third part of giving convincing results is also providing blue sky bounds, the future. So one example of this is, what if you had correct answers for all of your features, that your feature extractors never made a mistake? You can pretend that you had these perfect results by engineering them, and then see what kind of errors you get from that system in that case. So this shows that if you're dependent on a particular piece of software, if that software were perfect, could you do a lot better? Another example of a blue sky bound would be human ability on a task. So let's say that you're trying to build a machine that can automatically read handwritten letters on envelopes. Let's say that your system is getting it right 94% of the time. if humans can only get it right 96% of the time, then that's an important number to know, because it's unreasonable to expect machines trained with human data to do better than the imperfect humans that are providing you these data. If your boss comes and tells you, I want this automated system to get above 97%, you can come back and say, well, even our best humans can't do better than that. So I encourage you to read carefully the reading on evaluation in natural language processing that I linked to as part of this reading. It tells a very nice story about how to evaluate and communicate results. It's focused on natural language systems, but many of these ideas are applicable to just about any kind of system that you could create. And I encourage you to think about these problems when you're coming up with an idea for your final projects, and also when you're communicating your results in homework number 3. Much like feature engineering, a lot of this is more art than science, so it takes some practice. Be sure to ask questions, look at examples, and hopefully you'll get a feel for what makes for a convincing story about a machine learning system working well. So to wrap up, today we talked about the entire life cycle of a data science or machine learning project. In the beginning, you start with some data without any labels. You then work to establish a classification scheme. Perhaps you refine it to get good inter-annotator agreement. Once you have a good labeled data set, you then work with feature engineering to create a good system for automatically classifying some data. And then you communicate your results. You show that you have an interesting problem and that you did a good job of solving it. And in many ways, this serves as a good summary for everything that we've done in the course so far. We started off with giving you a lot of tools to interact with data, to make visualizations. This is important for communicating whether you have a good method or not. Then we talked about different classification techniques. These are all things that you would want to try to get a good system. And now we've talked about the tools that you need to communicate and to refine these systems to do the very best that you can on interesting, challenging, real-world problems. At this point, I strongly encourage you to start thinking about what sort of projects do you want to tackle to try out these new skills that you've learned, and to demonstrate that yes, we can build good systems to automate processes that we care about. Check out the webpage for more information on the project.